Okay, so chapter 10, special probability distribution. So this is still normal distribution. We're gonna do a few example on normal distribution, on how to standardize into a standard normal distribution and to calculate the probability. Okay, so let us go straight away to the example. Okay, so example 1, the average number of hours a student spend on the computer is 3.1 hours a day. Assume that the standard deviation is 0.5 hours. Find the probability that a chosen student will spend. So this is what we want to calculate. So let X be the number of hours. So let X be the number of hours a student spend on the computer. Okay, so we can say X is normally distributed. So the mean is 3.1 because we have average 3.1. The standard deviation is 0.5, so that means this one should be 0.5 square. So remember, the second one is a variance, so you should square standard deviation. So A, probability less than 3.5 hours. So we are looking at probability for X less than 3.5. Okay, so after this, we have to standardize them. So change it into Z. So this is probability of Z less than. So the formula is Z is equal to X minus mu over sigma. So we're going to use this formula. So 3.5 minus 3.1 over 0.5. So this is probability of Z less than 0.4 over 0.5, so this is 0.8. So we are looking at probability of Z less than 0.8. So if you didn't know how to calculate it, perhaps we should look at our bell shape. So the middle one is always 0 because this is a standard normal distribution. So 0.8 should be on the right hand side, Z less than 0.8, so that means this is on the left hand side. So we want to calculate the region on the left hand side. However, the way we read our table is always to the right hand side. Therefore, I should take the total probability 1 minus with probability of Z greater than 0.8. So now refer to your table, probability of Z equal to 0.8 and check what is the value. Okay, so this is 1 minus 0.2119. So the answer for this one is 0.7881. So that is for part A. So now let us see B. So B between 3 and 4 hours. So we are looking at probability for X in between 3 and 4. So do remember, if we have between, we don't have any equal sign for the X. Okay, so standardize them using the formula. So this is 3 minus 3.1 over 0.5 less than Z. So since we have already standardized, change the X to Z. And then 4 minus 3.1 over 0.5. And then simplify them. So this is negative 0.2 less than Z less than 1.8. Okay, so now we need to know how to calculate this probability. So perhaps drawing the bell-shaped curve, that will give us an idea how to calculate it. So the middle part is 0. We have negative, so the negative 0.2 is on the left hand side, positive 1.8 is on the right hand side, and then the region is somewhere right in the middle. So that means I should take the total probability, which is 1, minus the left hand side as well as the right hand side. So I should take 1 minus probability of Z less than negative 0.2 minus probability of Z greater than 1.8. So negative 0.2 to the left hand side, so less than negative 0.2, 1.8 to the right hand side. So once we deduct the left hand side and right hand side, we're going to get everything right in the middle. Okay, so if you refer to the table, we don't have anything with negative, so I should check what is this z less than negative 0.2. So again, draw the bell-shaped curve. So the middle part is 0, the left hand side is negative 0.2, z less than negative 0.2, so this is the region. Therefore, you should take the symmetrical of this, so flip it. So flip them, you're gonna get positive 0.2, so instead of going to the left hand side, this is going to the right hand side. So if this one is z less than negative 0.2, this one gonna be z more than 0.2. So we can take 1 minus probability of z greater than positive 0.2 minus probability of z greater than 1.8. So since both of them are already greater than, I can use the table and read the table straight away. So z greater than 0.2 is 0.4207 minus z greater than 1.8, so 0.0359, and the answer for this one is 0.5434. Okay, so let us go to the second example. Okay, so the second example, the age of the member in a community is normally distributed with mean, so we didn't know what is the mean, mu, and variance, sigma square. So let me write down, let x be the age of the member in a community. Therefore, x is normally distributed with mean, and we didn't know what is the variance, so sigma square. Okay, so if there are 10% of the members with age more than 70 years, okay, so probability for x greater than 70 is equal to 10%, or you can simply change this one to become 0.1. So 10% is 10 over 100, so that is why we get 0.1. And then probability age less than 40, so less than 40 is 20%. So x less than 40, this is equal to 20%. So 20 over 100, so this is 0.2. So let us do the bell-shaped curve to see where is 40 and 70. Okay, so basically if this is the x, the mean is mu. So now we have to decide where is 40 and 70. Are both of them on the right hand side, or are both of them on the left hand side? Or are they should be one on the left, one should be on the right hand side? So we need to decide about that. Okay, so x greater than 70 is 0.1. So you have to remember the properties. If this is mean, that means the left hand side is 50%, the right hand side is also 50%. So in order for x greater than 70 to be 10%, that means 70 should be on the right hand side, so that this region over here is 0.1. If let's say you put 70 on the left hand side, then it should be bigger than 50%, because we should take everything on the right hand side of our mean. Okay, so now x less than 40, so we should decide whether should we put on the left hand side, or do we have to put on the right hand side. So if let's say I put them on the left hand side, less than 40, so this one is definitely 0.2. I can write them down on the left hand side. So this one is 0.2, and you should be able to see that this value is less than 0.5. So if 40 is over here, less than meaning that we're going to take everything on the left hand side. Therefore, if 40 is here, the probability should be more than 50%. Okay, so now let us standardize everything and use the table. So probability for x greater than 70, so this is 0.1. Standardize, so probability of z greater than 70 minus mu over sigma, this is equal to 0.1. So based on our table, this is also probability of z greater than, so look at the table and find the value such that the probability is nearer 0.1. So this is 1.28. Okay, so since this is z greater than, this is also z greater than, I can simply take this value and let them be equal. So 70 minus mu over sigma, this is 1.28, or 70 minus mu is equal to 128 sigma. So this is the first equation. So let us see the second equation. So we have probability for x less than 40 is equal to 0.2. So this is probability for z less than. So this is 40 minus mu over sigma. And this is 0.2. So based on your table, you should be able to see that for 0.2, z should be greater than 0.84. Okay, so now as you can see, this is z less than and this is z greater than. Therefore, we have to change one of them in order to make the number behind equal. So let me change this part. So I know that if I have z greater than 0.84, this is z greater than. So this is similar to z less than negative 0.84. So I can simply change this one to become probability of z less than negative 0.84. So now both of them we have less than, so we can easily compare the number behind. So we got 40 minus mu over sigma is equal to negative 0.84, or 40 minus mu is actually negative 0.84 sigma. So that is the second equation. So first equation, second equation, we should try to solve them simultaneously. So to solve them, use the first equation minus the second equation. So we're going to have 70 minus 40, so 30. Negative mu plus mu, so that one will become 0. 1.28 plus 0.84, so this is equal to 2.12 sigma. Therefore, sigma is equal to 30 over 2.12, where sigma is simply equal to 14.15. And then of course, to calculate the mu, so we got 70 minus mu. This is 1.28 multiplied with 14.15. Therefore, the mu is simply equal to 70 minus 1.28 multiplied 14.15. So this is equal to 51.89. So that is the value for our mean as well as our standard deviation. Okay, so that's it. So I'll see you in part 3.